In 2006, a team of German physicists at the University of Dresden placed a fragment of a legendary 10th-century weapon under an electron microscope. They expected to find primitive, uneven iron. They expected to see the sloppy metallurgy of a dark age. Instead, they found something that shouldn't have existed for another 1,000 years. Deep within the steel matrix of the blade, interwoven between the bands of iron, were perfectly formed carbon nanotubes. These are ultra-futuristic, microscopic cylinders of carbon atoms. Today, aerospace labs like NASA spend billions of dollars trying to synthesize them to build next-generation spacecraft, body armor, and microchips. They are one of the strongest, most flexible structures known to modern physics. Yet, 1,000 years ago, an ancient blacksmith working in a dirt forge, without a thermometer, without a microscope, and without a single shred of formal scientific knowledge, managed to manipulate matter at the atomic level. They didn't just stumble onto nanotechnology, they weaponized it. To understand how impossible this is, we have to go back to the 11th century, to the height of the Crusades. European knights, encased in heavy, thick iron armor, advanced into the Middle East. They believed their steel was the finest in the world. They were wrong. When they clashed with Islamic armies, they encountered weapons made of a mysterious metal the Europeans called Damascus steel. The stories that traveled back to Europe sounded like outright sorcery. It was said a Damascus blade could slice a floating silk scarf in half in midair, a feat impossible for heavy, blunt European swords. More terrifyingly, these blades could cut clean through a European knight's iron helmet and shield in a single strike without ever losing their edge. But the most bizarre property was their flexibility. A true Damascus blade could be bent almost 90 degrees into a crescent shape, and when released, it would snap right back, perfectly straight, without cracking. In the laws of traditional metallurgy, this is a paradox. If steel is extremely hard, it becomes brittle like glass and shatters under heavy impact. If steel is flexible, it is soft, meaning it dulls quickly and bends out of shape. You can have hardness, or you can have flexibility. You cannot have both. But Damascus steel defied the rules. It was a material science anomaly. For centuries, scientists assumed these historical accounts were just exaggerated wartime propaganda. That is, until that German research team, led by Dr. Peter Porfler, actually got their hands on an authentic Damascus saber. To understand what they discovered, we need to look at what steel actually is. At its core, steel is just iron mixed with a tiny amount of carbon. If you add too much carbon, you get a material called cementite. Cementite is incredibly hard, but it is so brittle that a hard blow will cause it to snap. When the researchers looked at the Damascus blade under the electron microscope, they discovered that the ancient smiths had achieved a masterclass in microscopic structural engineering. The steel was made of alternating layers. One layer was soft, shock-absorbing iron. The other layer was composed of ultra-hard nanowires of cementite. But these brittle nanowires weren't floating freely. They were completely encased, shielded, and reinforced by carbon nanotubes. Think of it like modern reinforced concrete. Concrete on its own can handle weight, but it cracks easily under tension. To fix this, modern engineers run high-tensile steel rebar through the concrete. The carbon nanotubes inside the Damascus sword acted exactly like microscopic rebar. They wrapped around the brittle cementite nanowires, giving the blade its legendary, unyielding strength while allowing the iron to bend without snapping. The swirly, watery pattern on the blade wasn't just decoration. It was the visible macro pattern of an atomic-level lattice. The ancient world had successfully engineered a metal matrix composite, and they did it using wood fire and muscle. How did they do it? Did a 10th-century blacksmith understand quantum mechanics? Absolutely not. The reality is actually much more fascinating. The secret didn't originate in Damascus at all. Damascus was simply the trading hub where the swords were sold. The raw metal came from a highly specific region in southern India, where it was known as Wootz steel. The Indian metallurgists would place iron ore into small, sealed clay crucibles, along with specific local plants, leaves, and wood. They would seal the pot completely airtight and bury it in a furnace for days. As the wood and leaves charred inside the sealed, oxygen-deprived pot, they released carbon. But they also released something else. The local wood and leaves contained high amounts of complex organic molecules. Furthermore, the specific Indian iron ore used was naturally contaminated with ultra-rare microscopic trace elements, specifically vanadium, tungsten, and manganese. As the crucible baked at temperatures exceeding 1,200 degrees Celsius, these trace impurities began to line up in perfect rows. When the blacksmiths hammered and stretched the metal over and over again, these rows of impurities acted as chemical catalysts, forcing the carbon atoms to naturally bond into perfect, microscopic hollow tubes. The blacksmiths didn't know what atoms were, but through centuries of meticulous trial and error, they had perfected a highly specific, repeatable recipe that forced nature to assemble its own nanotechnology. They were practicing chemistry disguised as alchemy. And then, around the year 1750, the fires went cold. Suddenly, sharply, the production of authentic Damascus steel completely stopped. Within just a few generations, the secret was entirely lost. Blacksmiths across the world tried desperately to replicate the swirling patterns and the physics-defying strength, but every attempt failed. For nearly 300 years, the recipe remained a ghost. Why did it vanish? The answer comes down to a fragile supply chain. In the 18th century, the specific iron mines in India that contained those exact, magical trace amounts of vanadium and tungsten finally ran completely dry. Because the blacksmiths didn't know why their recipe worked, only that it did, they didn't realize that changing the source of their iron ore would destroy the entire atomic reaction. When they began using iron from other mines, the trace catalysts were missing. The carbon nanotubes stopped forming. The blades began to crack. The magic was gone. A multi-billion-dollar military industry that had dominated the medieval world for 7 centuries collapsed practically overnight, simply because a single trace element disappeared from the earth. The story of Damascus steel isn't just an interesting historical footnote, it is a stark warning. It proves that a civilization can possess world-altering, advanced technological mastery, and yet, if the delicate thread of knowledge and resources is cut, that mastery can evaporate into myth in less than 50 years. It makes you wonder, what other industrial secrets did the ancient world master that we are currently spending trillions trying to reinvent from scratch? Next week, we are diving deep into the earth to look at a massive, geometric stone matrix built in ancient India. A system so mathematically complex that modern engineering software still struggles to calculate how it handles millions of gallons of water without a single pump or pipe. Hit subscribe, turn on the notification bell, and don't miss it. This is Lost Wise.